Hello, everybody, and welcome back. Welcome back indeed. We're looking at question 2 as we continue the 2012 Euclid paper that we started in the last video. So we got two light bulbs and a full written solution question, just like in question number 1. So A, if ax plus ay is 4 and x plus y is 12, what's the value of a? Okay, no sweat. You can take out a factor of a, just get a single a over here. And look at that, we've got a times x plus y, but we're told what x plus y is. It's 12. So now if I divide both sides by 12, I'll get a is 4 over 12, and I would probably write that as 1/3. Okay, simple rearrangement. It's a light bulb, so we don't have to show all this work. We could just write down 1/3, but it's clear, and we didn't write any words. It's very clear what we're doing from our equations. Okay. So now we're up to 2b. If the lines with equations 4x plus 6y equal 5 and 6x plus ky equal 3 are parallel, what's the value of k? Okay. So how we approach this question depends on what we know about this particular form of the line. And this is sometimes called standard form or general form. And so you're probably more familiar with y equals mx plus b. Okay? And you know that parallel lines with y equals mx plus b have the same slope. So we'll say y equals mx plus g or something like that. So you can very easily find parallel lines that way. But when it comes to this form, it's not as gone over, I find, in most high schools. So you can be forgiven for wondering, how do you tell if two lines are parallel? Well, two lines are parallel not if they have the same a and b, but if they have a multiple. So we'll say n times a and n times b. Okay, as long as you got multiples there, you'll have parallel lines. And this will be some other letter d. Okay, so if you know that, and we know our one line looks like this, then our other line needs to look like, well, it's got to have a coefficient n times 4 and n times 6. And then I don't really care what the other thing was. I think it was a 3. But we know this equation has 6x plus ky. So 6 is 4 times n. N is 3 halves. And so now I can take that and say, oh, k is 6n. 6 times 3 halves, we'll get k is 9. Okay? And that's all we're looking for is 9. Now that's if you know this standard form or general form and how to recognize parallel lines. If not, that's okay, we can still do the question. You're probably more comfortable with y equals mx plus b, so your first step would be rearrange this so it looks like y equals mx plus b. We don't really care what the constants are. Okay? And now the other line, 6x plus ky equals 3. Rearrange that. Ky is negative 6x plus 3. Divide by k, and you'll get minus 6 over kx plus 3 over k. But again, we don't really care about the constants. It's more about these slopes. They have to be the same. So minus 2/3, or minus 4 over 6, needs to be the same as minus 6 over k. I'll divide by negative 1 on both sides. 2/3 is 6 over k. You might be able to do this in your head. If not, you can multiply by k on both sides, multiply by 3 on both sides, divide by 2, and you'll get k is 9 that way. So you can do it either way. You don't have to show both methods. It's a light bulb. If you just wanted to guess 9, that would be fine as well. But there's two different ways. And if you're unfamiliar with this form of a line, I would suggest you add it to your knowledge. It can come up. That's a good one. Y equals mx plus b is good. It's nice because you've got the slope sitting right there, and you know the y-intercept. Another good one is y equals mx minus a. This is called the x-intercept form. It can be helpful. So a0 is where the line crosses the x-axis. Okay? These are good forms. Another form, just while I'm talking about it, is something called point-slope form. Okay? M is still the usual slope, but x naught and y naught is a point on your line. And this one's not as nice because it's not unique, but it's really helpful in the right situation. And certainly, if you end up taking calculus later in high school or early in university, they tend to use this form a fair bit. So it's useful to know. Okay. But let's move on from 2b. Let's look at 2c. Determine all pairs x and y that satisfy the following system. X plus y is 0, x squared minus y is 2. And remember, we've got to show our work. Okay. So I've got these two nice expressions here. Now, what can we do? Well, the first one, I can bring the y over to the other side and see that x is minus y, or x is y. Either way is fine. So if I can find x, I can find y. If I can find y, I can find x. Now, look at the y's here. You've got plus y in the first equation, minus y in the second equation. If I were to add these expressions, x plus x squared, it's like this, but y plus negative y is just 0. And then 0 plus 2 is 2. So whatever x is, it's got to satisfy this quadratic here. Okay? So any part of an xy pair that satisfies these equations will have to have x satisfy this quadratic that we've just created. Okay? And we can factor this. You'll get plus 2 minus 1. So either x is minus 2 or x is 1. Simple as that. But now that I know what x is, y is just the negative. So my pairs xy have to be minus 2, 2, or 1 minus 1. And there we go. That's all there is to it. We only had 2 possible pairs. But we clearly, we showed how to combine our equations. We showed how x and y are related, and all with a very, very small amount of words. That does question 2 quite nicely. Up next, of course, question number 3, as we continue our look at the Euclid page.